Hey everyone, welcome to chapter 2 of this course. Chapter 1, we're just looking at the high levels of what the course entails. We looked at a couple of algorithms. We talked about supervised learning, and then we jumped into unsupervised. And we talked about challenges that data scientists face, 6 challenges. And then we looked at 4 ways to improve on those challenges, like things like dimension reduction, different algorithms under that, clustering, different algorithms around that, under that, anomaly detection, that's another one that we looked at. And let me actually verify from my notes what the fourth, anomaly detection was number 4. Number 3 was actually feature extraction. So feature extraction, when you looked at autoencoders. So in this one here, we say this chapter we're going to dedicate it to a project that is supervised learning, from the supervised learning field, because what we want to do is we want to see what we're used to. We're used to doing projects in supervised learning, so let's start off with a supervised learning project, right? And when we do that project, when we do other topics like chapters, right? Let me just say project. When you do other topics, we'll see how we can improve on this supervised learning project. So let's get into this. Is just an introduction video, and then we'll get into the content from the next video going forward. So in this chapter, like I said, we're going to look at a supervised learning model, keep track of the metrics, and see how we can use unsupervised in upcoming chapters to improve on this models that we are going to build. It's actually we are actually going to build a couple of models. The models we're going to build a logistic regression model. We're going to build logistic regression, and we're going to build a random forest. We're going to do XGBoost, and I think we'll also look at a light GBM model. And if you can already tell, this is definitely going to be classification. We are classifying here. Doing classification. But what are we classifying? We are classifying whether a transaction is fraud or not fraud. So it not being fraud is that a transaction is genuine. That's what we will be doing. So it's a binary classification case. Makes sense. We're doing logistic regression, right? Logistic regression works with a binary case, unless you're doing like one against all, but still binary case. So this works perfectly. When it's fraud, it is 1, and when it's not fraud, it is 0. But where is this data? So this data that we're going to get the data from Kaggle, and this is the link to the dataset itself. I'll put the link in the description of the video. Kaggle.com, MLG ULB, and then it's going to be credit card fraud. So if you go to this link, you find the description of the data, and you can download it, and maybe you can see what other people have done with the data and stuff like that. This data, when you read the description of the data, right, these are points that I need to highlight right now. When you are building these classifiers, we are going to work with a data set that is imbalanced. It's highly imbalanced. It's very, very imbalanced. It's an imbalanced data set. How imbalanced? Actually, only 492 of the 284,807 transactions are fraud. So only 492 out of all these transactions are fraud, and that is a fraud rate of 0.172%. So you can just imagine how imbalanced this data set is. It's incredible. It's highly imbalanced. It's incredible, but it is what we want when we're dealing with fraud data sets. Fraud data sets have to be imbalanced, because it means that all the other checks and balances caught out all the other fraud. It struggled with the 492, of course, but having such a low fraud rate means the checks and balances were working. There might be rule-based checks and balances. If a transaction is of this much amount, we never expect it, just just make it fraudulent and stuff like that until a human looks at it and all of that. So we expect that all the other checks and balances that humans can put in place, they will stop the fraud. But the ones that go through that we will eventually find out about. Let's say a client calls us, like, guys, I've just lost this money, and then we investigate. That's the 492. We'll be like, so it was actually fraud. Our rules didn't catch it out. But those guys now, the fraud department will come to you, be like, dude, we want you to build a machine learning model. We've heard that machine learning can do some wonders that us humans can't do, and they give you this data set that is so imbalanced. But you have to deal with it. So we're going to see how to deal with it. We're going to see how best we can deal with it using supervised learning, and then see how we can improve on supervised learning using some of the unsupervised parts. So that is that. And then another thing that I wanted to emphasize. So this is one part I wanted to emphasize about the data. The data is 28 variables. So some of the variables, if you look at them, we have variables v1, v2, v3, etc. When you look at the explanation of the data, they say these variables were created from principal component analysis. So actually, the data set could have had many variables, could have had 100 variables, the original data set. But when it was then uploaded to Kaggle and people worked on it, the one that you find on Kaggle actually went through some dimension reduction algorithm. Dimension reduction. So they did principal component analysis and came up with these variables v1, v2, v3, these principal components. You understand these better when we do principal component analysis, but these are principal components that came out of dimension reduction, and it drilled it down to this v1, v2. So the original data set itself could have been so many variables, but they did PCA before they gave us the data set, which is good, because at least they removed maybe the noise that was there in the data set. It is bad because we can't really describe what V1 is. We don't know what V1 is. We don't know what V2 is. We don't know what V3 is. So the original data set could have had age, gender, all of those, but they're now hidden in these principal components. You see when we do PCA what I mean, as in they are hidden in there. They are not the original features. No longer the original features. But along with the principal components, we have other variables that were added, which is time of transaction, that we can describe just the time when the transaction happened. And we also have the class of that transaction, class being whether it is fraud, and this is equal to 1 when it's fraud, or not fraud. When it's not fraud, then the class is equal to 0. And another one that was maintained that didn't go into principal component was amount of transaction. So those were not put into the principal component analysis to drill down the 100 or whatever dimensions they were. So these were maintained. So on top of these principal components, these are the other 3 that were maintained. I think it's only that, right? If I recall well. If I'm making a mistake, you can just look at the Kaggle page. They will explain exactly what the variables are going to be. Yeah. So that is that. So in the next video, we're going to use this data set. We use Python. We're going to use Python to take in the data set. I'm not going to really go in. So the code you're going to find, I'm going to put a link where you find all the notebooks. I'll be working in Jupyter notebooks. I'm not going to code it. It's already written. I'm just going to explain a few things on the Jupyter notebook, but others I'm not going to write it. Because the point of this course is not to get so caught up in the coding itself. It is to explain the principles. So that's what I'll be trying to do. So I'll send the link will be there in the description of the video, the GitHub link, where you can just download or clone the project and stuff like that. What else do I want to explain? Yeah, so the emphasis is just Python. And if you do not have the packages, it's just a matter of pip install and stuff like that. You can Google some of the errors if you find some of the errors, but the codes are working. So I'll see you in the next video. Just set up your Python environments for now if you don't have already. If you do, let's get into the next video where we acquire the data. We get the data. But for me, it's already downloaded. So you can download the data, the CSV file, download the CSV file, and just import it like I'll be doing in the next video. So see you there.